Welcome, everyone. Thanks for sticking around for Friday. And hopefully you're here to talk about deployments. And it's also Friday, so I'm hoping none of you are doing deployments because you want to have a good weekend, right? So we're here to talk about deployments and what could possibly go wrong. And the answer to that is obvious. Who here has ever deployed bad code and had a horrible weekend because of it, right? I mean, we all have. If you haven't had that, chances are you haven't deployed code into production. So I love this meme. It's the most interesting man in the world, Dos Equis guy. But the meme for us in technology is when I do blank, I do it in production, right? My friend Bridget calls this YOLO ops. You just roll it out and see what happens when it goes into production. And the problem that we all have is that when we deploy to production, we have to do that in production. As much as we try to plan that our development environments are the same as the staging environment, and that's the same as production environments, and that when code works on somebody's laptop and it gets pushed through, it's going to be the same all the way across, and then it's going to deploy just fine, right? The problem is, as much as those environments match, it always happens that code gets through, it doesn't get caught in test, or something happens. And worse than that is when the code passes all the tests and the code is actually functional code. It's things that work the way we think it should. And the problem is us. It's the problem that we designed an application or a feature that doesn't actually work the way that our users or our customers think it should. So it's really easy to not only just deploy bad code, but to just deploy bad applications. So that's why I think Canary deploys are really the future of how we ought to be deploying. So before we dive into that, a little bit about me. Who am I? Why am I talking about this? I'm Jason. I'm a technical evangelist at Datadog. I'm a nomad, so I've lived the past year out of 2 suitcases, traveling the world, over 18 countries, 60 cities, and so now I currently live here for at least this part of the week. I'm also a whiskey hunter, so I travel the world looking for whiskey, interesting whiskey, although whenever I'm in the Netherlands or Belgium, it's usually Jenever. And then I am a Pokemon player. Yes, people still play Pokemon Go. If you see me wandering around later, I'm not lost. Like, don't worry about me. I'm probably just trying to find a Pokemon. If you, like me, play, that's my friend code. Feel free to hit me up. There's also a bunch of Pokemon references in this deck, so I apologize for that if you don't like Pokemon. That said, a little bit about Datadog, since they do employ me and finance some of my travels, at least to come and speak with you about things. Datadog is a SaaS-based monitoring platform, so we do infrastructure and application metrics, we do performance monitoring, and we do log analytics all within one application to try to help you understand what's going on in your systems better. Give you an idea of the scale of what we handle. We do trillions of points of data every day for thousands of customers. So we handle a lot of data at very, very large scales. We are hiring, so we're hiring all across the board. If you're interested in building really cool tools for other engineers, other developers, come talk to me later. We'd be happy to have you. So all of this said, I know Kubernetes and Istio are both in the title, which makes a lot of people come to the talk because they're interested in those. I used to have this note in my slides because I gave an earlier talk, earlier version of this talk early this year. And my friend Kelsey Hightower, who's widely known in the Kubernetes world, said this: Istio is a very early project. Don't run out of here and deploy it in production. You'll end up on the news in a bad way. And this was in February, so Istio was version 0.6 at the time. I have updated advice, though. Istio is 1.0, and the APIs are stable, well, mostly stable. You should go out and try it. And you should trust me more, because I think I have better hair than Kelsey. No, there's no reason that you shouldn't try Istio, and if you get anything out of this talk, beyond the Canary deploys, it's that Istio is a great project. It's come a long way in just the 9 months since Kelsey was warning people that it was a little too early for production. It is ready for production. So what you're going to see in this talk a little bit later, I think everybody should go out and play with it, give it a try. It's going to give you a whole lot more control over your Kubernetes infrastructure than what you've got today. So that said, back to the topic at hand. How are we doing deployments? Who here is doing BlueGreen deployments? Yeah, okay, a fair number of you. For those who aren't sure, because they're random colors, some people call it red-black. The colors really don't matter. So if you are confused, the concept is really simple. You have blue, which is version 1 of an application. You have green, which is version 2, and you have a load balancer that sits out front. And that load balancer just switches between them, right? And the load balancer could be an actual load balancer, or it could be as simple as DNS, or if we're thinking of things like Capistrano deployments, it could just be a symlink, right? That's pointing from one version of the code to the other. And the pros of this were always that there was zero downtime deploys, right? In the time that it takes to make that switch, to update that symlink or make the DNS change and roll it out, there's really no downtime in there. It was almost instantaneous. And there was always the pros of easy rollbacks, right? If something went wrong in version 1, you could just redirect traffic back to version 2. I like to think of it as a big undo button. The problem with this, though, is the cons were easy rollbacks. And I say that with air quotes. How many people have rolled out a BlueGreen and rolled back and it didn't work? Few people. This is really common. If you've ever had a deployment where there was a database schema change or something that wasn't necessarily part of the code itself, right? Some developer decides to add a new feature, maybe adds or changes a column in your data store. You roll out version 2, everything looks okay, then suddenly it breaks, so you try to roll back, and suddenly your data store is no longer compatible with version 1. I used to be a Drupal developer. This was very, very common back with Drupal. So then we moved beyond blue-greens, right? So rolling deployments. Rolling deployments, if you're using Kubernetes, is the standard way to do deployment. And the concept is actually quite similar to blue-green. You start with now replicated sets within Kubernetes, and you just slowly tear one down, spin up version 2, version 3, and then eventually everything becomes the new version of your software. And this was generally great. It gave us the one added benefit, aside from having replicas, that you're always maintaining sort of version 1 and version 2, so there's always the ability to roll back. So what does Canary deployments get us, right? Well, if you're not familiar with Canary deployments, the concept is really simple. It's essentially this. If I am up here in front of you in this giant theater, and I do something stupid, would I rather have this place be completely packed, or would I rather have it be empty? Right? With a Canary deploy, the idea is that we're rolling out to just a few people, a smaller audience. So how does it work? Well, similar to rolling a deploy, we start with a bunch of replicas of our software. We roll over one, but rather than continuing to do this, which by default Kubernetes will do this with a rolling deploy and do this very quickly, we want to stop. We want to pause, monitor, take stock of how things are performing, analyze them. And then we'll continue on, and then we'll stop again, and we'll double check, right? And we'll continue to roll out increasingly more to our audience or our customers, and we'll continue to stop and monitor and see what's going on before finally doing the entire rollout. And that's when we party. So Canary deployments, really, at a high level, they give us a smaller scope, right? We can limit the blast radius. There's limited ramifications. If I roll out some bad code that has a horrible experience, well, I'm not going to drive all of my customers away. There's just going to be a few that experience that. And hopefully I can detect that with my monitoring and then roll that back. And it does have that easier rollbacks because we're constantly supporting the current version of production and the new version. There's no idea of I roll back and suddenly it's incompatible because we're always supporting those versions. It's also more load tolerant. And so this is something that I think a lot of people miss out on when they're doing Canary deployments. If we're rolling out a new feature and say that new feature makes stronger use of our data store, right? We're starting to make more queries. Well, that could be an acceptable thing, and we can start to scale up, right? We can add more replicas to our database to start to make our systems more load tolerant as we roll out. And the last feature that I think a lot of people miss out on is that there's a bunch of concurrency that you can have. You can start doing experiments. You can roll out multiple versions of that feature. And you can start to monitor to see which versions you think are better, which ones are getting more engagement from your customers. So all that said, let's talk a little bit about your Canary strategy. How should you think about Canary deployments? And the first way that most people think about it is random, right? I'm going to send 1% or 5% of my traffic to my new feature and see how that goes. And this is generally okay for certain things, like back-end APIs, things that aren't really specific to a user. But as we all know, if anybody's ever tried to do random on a computer, we just had a talk about encryption earlier before this. Encryption's really hard because we all know that computers don't do random very well. Random is not very random with computers. So when you think about Canary deployments, you really want to think about representative sets. Think about how your users are going to be using your application or that new feature. Think about the geography. If we roll out and we're doing a Canary test, well, are we only going to get our users here in Europe? What happens to our users that are in Asia or our users that are in North America? What time is it there, right? If we do a Canary deployment right now and we're looking in, hey, all the monitoring looks great, but we know that our primary user base is in Asia, well, that time sync means that they're end of day. They're not even looking at our web application. So we have to be aware of what time we're rolling out, and then also being aware of the usage patterns. So as you Canary deploy, if you were just say, well, let's just roll out randomly, but the new feature that we're rolling out is only for logged in users, then for most of those users, those anonymous users who are visiting our application, they're not going to see it. So start to think about the features that you're rolling out, particularly if you're on the ops side and you're setting up Istio and Kubernetes and you're working with developers, you really need that true DevOps experience here. You need to get the developers and operations talking together on what's getting rolled out and how to roll that out. The other thing that you have to think of for your Canary strategy is granularity. As I talked about canaries, you're rolling out a little bit at a time. Start to think about those steps, right? Especially if you're thinking of representative sets. You can't just say go from 5% to 10% if you're targeting specific users. Grubhub, who does online meal ordering and delivery, they're a customer of Datadog, but they've done a fantastic job they start with small towns. So they'll target a GeoIP service and notice people from a certain town. Start to roll out to them before they roll out to a smaller city, and then a mid-sized city, and then large cities, and then globally. And the last thing is, as I mentioned, Canary deployments can be much more load tolerant. You can start to scale your resources when that makes sense. So think about the resource mapping. As you roll out features, start to think about how's this feature using API endpoints, or how's it using data stores? Is it using more? Is it using less? Try to auto-tune or tune your infrastructure as that makes sense. Now, obviously, none of this makes sense unless you're monitoring, right? We can't deploy a Canary and then stop and wait and just sit there and hope that nobody complains on Twitter. We actually have to have a monitoring strategy. And the first is that we absolutely need tags. You absolutely have to be using tags, whether that's, in Datadog, we call them tags. If you're using Prometheus, they're called labels. You need some way to add metadata. When we think about a metric that we're gathering from our application, it can't just be a what is it and how much is it, a value and a timestamp. You have to add where it's from, an application, a host, things like that. The other thing that you have to do is start to look at the extremes, right? Look at how many people are looking at your P90 for things like latency, 90th percentile, 95th, P95, 99th. Yeah, not as many for that 99th, right? You got to start pushing out to those extremes because, again, with Canary deployments, we're rolling out to very small subsets. And so as those problems manifest in small subsets, it might just be a couple users. But as you roll that out to everybody, that's going to grow. So start taking a look at those extremes. One way that you can do that is with outlier detection. So if you've got any sort of machine learning or algorithmic anomaly and outlier detection within your monitoring solution, make use of that, because a lot of times when you're rolling out to canaries, you're not going to be able to visibly see that. You can't look at a dashboard and just see that something's out of place. I like to say that outlier detection is one of these things does not look like the others. Hopefully it takes you less than 14 days. But your outlier detection will make note of that, right? If you have hundreds of nodes or hundreds of pods in your Kubernetes, one of them that's acting strangely may not be visible to you, but easy for a machine to identify. Also, anomaly detection. I like to say anomaly detection is this isn't acting like it was before. So if you were looking at a graph, say, like this, can anyone spot the pattern? It's not so easy until you have some machine learning that actually takes a look at it and starts to group things. And we can see, oh, maybe there's some groupings by fives there. And it starts to make a bit more sense once you have machines looking at things and able to spot things like what happened on that Tuesday. So all that said, what should you be looking for? Well, I particularly like the 4 golden signals from the Google SRE book. When you're taking a look at your metrics, take a look at the latency, any changes in latency. Are things getting slower? Are things speeding up? If they're speeding up, that's usually a good thing. Take a look at the errors. Errors, not only the error counts, but take a look for new errors. As you roll out new features, inevitably you will encounter new errors. Then take a look at traffic. Again, traffic can go up, it can go down. This isn't good or bad either way until you understand your application. So if your traffic is going up, that could be a good thing. It could mean that customers love your new feature, they're hitting it more often, that's a win. But if your traffic's going up and it's not expected, maybe you are expecting less traffic because you optimize the system, well, that's a bad thing. Similarly, saturation. Take a look at your resources. How are those resources being used? Again, if resources are going up, and that's okay, you already understand that your feature was going to make more use of, say, that data store or some API endpoint, go ahead and ramp those up. But take a note of whether you're becoming more or less saturated. So I know that was a lot of really dry stuff about Canary deploys. Hopefully a lot of you already understood that. So what's all this have to do with Kubernetes? How many people think Kubernetes is a container orchestrator? Yeah, most people think that. I hate to say that you're wrong. It's a service orchestrator. And I say this is a service orchestrator because at the base level of what Kubernetes does for us is it manages services, right? Nobody cares about containers. Containers are ephemeral. They come and they go. You start a pod, something happens, it dies, it kills those containers, it starts up new ones. Containers mean nothing. Services are what we're about. Services are what we work on. They're the applications that we develop, or they make the applications that we develop. They're what matter. So when it comes to Kubernetes, well, if we wanted to deploy one service, it wouldn't really make sense to do like blue-green with that, right? Like have this giant mesh of all of our services and duplicate it numerous times and make it a simple switch. So Kubernetes, the great thing is it handles all this for us, right? Manages all our different services, and if we wanted to change one service or two services, it already does that, and so it'll do a rolling deploy. So why do you need a service mesh? Well, Kubernetes, as I mentioned, does rolling deploys really well. It does them so quickly that usually when you do a rolling deploy, it's impossible to get in there and actually pause it. By the time you're thinking, oh, I need to pause that and monitor, it's rolled over everything. So Canary deploys, not so much with Kubernetes. But let's say that we actually wanted to do this. How would we do this with Kubernetes? Just to illustrate. Well, we'd start with a service, right? Pretty basic service, web application here, got port 80 opened, nothing too complicated, and then you make a deployment. So for those who aren't familiar with Kubernetes, deployments are essentially the new way that you tell Kubernetes that you want it to spin up a bunch of pods and you want it replicated. So here I have a basic deployment. I'm saying that I want 3 replicas. I give it a little information, and then I tell it, which Docker image to pull. So if I do this, and I say, cool, I've got version 1, and I'm going to make another deployment with version 2, the same number of replicas, who knows what will happen if I do this? I have 1 service, 2 deployments for it. Anyone? Yell it out.
The label routing is not going to work, or it's going to pick up both because they have the same label.
Yeah, so, well, assuming that the labels are different, what would happen though?
Well, that depends on what your selector is. If your selector is just on one part of the label, it's going to route it to that. So you're going to change the service.
That's a okay, good response. It does depend on the selectors. So in this one, I'm just having it match label on my app, and we can see that the label here for my service is my app. So essentially, if I've got a service that has selectors that are not well defined, let's put it that way, because that is a good point. You should have good definitions on your selectors. But if I have a service that actually routes to do two different deployments because the selectors are matching, it pretty much does random, right? So it'll load balance between these two. So if someone were to come to my service here, try to get to version 1, they might get version 1 or they might get version 2. So how do we use this? Well, if we're going to do a Canary deployment with Kubernetes, like straight up Kubernetes, well, we could sort of do this, I guess, right? We could say have 9 replicas of one and 1 replica of the second one, and now we get a 90-10% split, right? And then I can ramp this up and do 8 and 2, and I'll have an 80-20% 3, and then 7 and 3. And you can see how this is really, really stupid, right? If I wanted to do a Canary deployment to 1%, I could do 99 replicas of one service or one deployment and 1 replica of the second. But again, not only is this stupid because I don't need 99 replicas, but it's also stupid because it ignores all that fine advice that I gave you about representative sets. So this is not a good solution. So what's a service mesh actually get us? Well, service meshes give us routing and load balancing. Like off the bat, they manage our network traffic for us, so they're able to do things like this. Service discovery. So the service discovery that you'll get out of a service mesh like Istio is quite a bit better than what you'll get from Kubernetes. You'll get timeouts and retries. So actually, Burr, who gave a talk yesterday about using Kubernetes and Istio as a web server or web application server, had a fantastic demo on this about how you could set timeouts and you could have it automatically retry for services that were failing, or you could have it route around those. It also has policy enforcement. How many of you trust all of your developers are making API calls with TLS encryption? Yeah, that's not a lot of trust. But you can handle that with Istio. We can automatically force and say, all of our network traffic off the bat, doesn't matter how the call is being made, we're going to just automatically TLS encrypt that. And then it also gets us monitoring and tracing, which I think is really cool. When we're having all of the network traffic go through Istio, it's a great way for us to see not only what services are connecting to other services, but we can start to time those and measure them. So we can trace a request across our entire system, see what endpoints it's hitting, see where it's taking the most time, and optimize that. So how does all of this work? It's not black magic. You really do 2 things. The first thing that you do is you add a data plane. So we're going to take all of our containers, we're going to shift them aside and put a sidecar there. And that sidecar is going to be Envoy. So Envoy is going to start taking over all of the network connections. So all of our pods or our containers are going to start talking basically locally to their own Envoy. And from there, then we add a control plane. That control plane is the guts of what is Istio. So that's where we have all of these cool features. So if we wanted to Canary deploy with Istio, how would we do that? Well, first thing is we'd have our service. Service is pretty much exactly the same. We don't do anything with our services. Services are just Kubernetes resources. They define services. They don't do a whole lot. When it comes to our deployments, though, when we're actually setting up the pods, what does that look like? Well, that surprisingly is also kind of the same. And I say kind of because there's not a whole lot you have to do. You'll manage your deployments in the exact same way that you have, but you'll do a fun little thing called kubeinject. So what we're going to do here is Istio-CTL is a binary that comes with Istio. We can actually take our YAML, inject Istio into it, and dump that out, and then apply that. So I'm going to quickly jump over here. So this is my service. Really, really basic again. Similar to what the slide showed. It's just going to set up a basic web application. And this is my deployment, right? So in this one, I've got 2 replicas. Hopefully I think that's large enough for everyone to see. But again, it's really, really basic. There's not a whole lot going on here. I'm just setting up, I've got a really basic web application, and I've got version 1. So I'm opening up port 80. So what's this look like? Well, I highly recommend that people do this when you're first using Istio. We're going to run the istioctl command. We're passing it kube inject, so the subcommand there. We're giving it a file, which is that deployment. So I'm just passing my deployment, the version 1 of my application, and I'm going to dump it out to another file here. And I highly recommend people do this because when we do this, it's going to generate that, and then now we can run a diff, right? So very much in the same way that people are like, how do you install software? Well, just curl it and pipe it to bash. Just trust me, right? What could go wrong? I'm always like, yeah, that doesn't sound so right. So I always recommend people do this manually, at least the first few times, to try to understand what's going on or visually see what's going on. So let's run a diff between our old version there and our new version. Oop, that's version 2, version 1. All right, so that just dumped out a bunch of stuff. But the main difference is here, like there's not a whole lot there, that's just stuff. There's a bunch of arguments here, but really what it all leads up to, and a bunch of environment variables, is that we are actually going to be setting up the Istio proxy. So the Istio proxy is Envoy, essentially what I said before. It's going to be setting up that sidecar. So whenever we deploy this deployment, it's going to set up my application, but it's also going to set up another container for us within that pod. The other thing, as we scroll down, is we see that we've got an init container. So for those of you who aren't familiar with Kubernetes, init containers essentially are containers that will run prior to your container running or your pod starting, and it'll make changes, and then it'll shut itself down, and your stuff will run. And what this is going to be doing is essentially down here, it's going to be running this Istio proxy init container, and that really is just there. It's going to modify our IP tables for us. So by modifying those IP tables, now our pod isn't talking directly to Kubernetes. It's going to be talking to that Envoy sidecar. Pretty straightforward. So that said, manually is not a great way to do this. If you're doing this a lot in production, like you said, you should only do it the first few times, start getting an understanding of what's being changed. But the way to do this is actually with mutating webhook admission controllers, also known as Autosidecar injection. So one of the cool things with Istio is that it's got a service that runs. If you label your deployments with the Istio tag, it will automatically modify them for you. So all you have to do is deploy in the standard way that you're used to with Kubernetes. So Istio is a service mesh, right? So we're all about service-oriented. So let's take a look at how we actually do this. And it all involves gateways, virtual services, and destination rules. So I've got a basic Kubernetes that's set up at this location. There's nothing there right now if you go to hit it. But hopefully you guys will all hit it later once I start getting this going. Cool. So let's actually go and apply some stuff. So I made that diff there. And I'm just going to do this. So I've got 2 versions of my application in various YAMLs. I've applied Istio to them. They're down here. So let's do, and then I've got that service. So let's do kubectl apply and add my service. And then I'm going to do kubectl apply, set my deployments, v1 and v2, right? So those are all pretty much the same way that we deploy with standard Kubernetes. What do we need now to get Istio working? Well, now we need a gateway, right? We need a way that when traffic comes to Kubernetes, that Istio knows about it. So Istio has a service called the ingress gateway, and it's got an egress gateway as well, and standard ingress stuff. So essentially, we've got just a file here that defines our gateway that says when things come in, what's going to happen? Well, it's going to use the Istio ingress gateway for it. And then we can tell it which servers, like how to actually to specify what we want to hit. So in this case, we're telling it that essentially all hosts, so we've got just a star there, all hosts, port 80, we want them all to be handled by our Istio Gateway. So let's go ahead and apply that. Cool. So that's all created. Now that we have a gateway, what happens? Well, as mentioned, Istio is service-oriented, right? So we have services in Istio. So it starts with what's called a virtual service. A virtual service pretty much is the way that we're going to define, again, similarly to how Kubernetes defines a service, it's how Istio is going to define our service. Really, all we've got here, though, is we give it a name, we tell it what hosts. So in this case, since it's my basic example, I've only got the one. And then we tell it that gateway. So we want to tie this back to that gateway to ensure that it's accessible. And then we just give it a routing, right? So we're telling it, route all HTTP traffic to the destination Canaries, which is defined by destination rule. So destination rules are what I like to say are the glue between Istio services and Kubernetes deployments. So we can see here that we've got our destination rule defined. It's on our Canaries host. And here's where we're setting the subsets or the versions. So essentially what I'm going to be doing is tying this version 1 here to the label that's in my deployment. So let's go ahead and apply these. Cool. So at this point, we should have something up and running. So I'm going to go ahead and hit this. It is, again, bit.ly/cd-devoxx. Cool. So I get version 1 of my application, right? It's always going to be, oh, I have version 2. Apparently let's go see what I've got running. Hey, I forgot to tear things down before. Cool. Well, spoilers. Let's see what those spoilers are, actually. So, because I had actually applied these in testing and not torn them down before running this thing, what are we actually running in production? Well, again, virtual service. So now we've defined our virtual service, but we'll see that I've added a few things here, right? I've got not only just that routing and a destination, but now I've got a wait, and I've got this second destination, which is version 2, which is why that came up. So the way that we tie this again is this version 2 here, what we're seeing, this subset, ties to the subset here, right? So we've got subsets. I had version 1 in my destination rule. Now I've added version 2. So that's how we tied things together. Let me go ahead and just reapply these to make sure that things are working. All right. So that's all working. So what we saw there is I had it for 90%, actually. Let's do. Let's reopen that. All right. So I've got it for 90% for version 1, 10% for version 2. So I could sit here and keep hammering this website, or if you guys want to open up your phones or your laptops, again, that was bit.ly/cd-devoxx. Go ahead and hit that. And I'll just keep refreshing this. And eventually it'll give me 2s occasionally. For those who have hit it, how many got version 1? How many got version 2? Yeah, so a few people up here. But pretty much everyone got version 1, because again, we set that for 90%. So as you can see, that's much easier for me to set up, right? Now if I want to tune things, I don't have to do that silliness of 99 replicas and 1 replica as we would in Kubernetes. We could just set these rules within Istio. Cool, so that's really basic though. That's pretty much random. And I gave you all of that advice before about how you should do things more than just random, right? That sending 10% of traffic really is a horrible way to do Canary deploys. So what else can we do? Well, let's take a look at this. So I've got a virtual service version 3. One of the cool things about Istio is that we can see here we have this matching, and we can match on headers, and we can match on a bunch of other things. But headers gives us a lot of information. So if we're thinking about, again, places like Grubhub that are doing GUIP lookup to see where people are at, you can mimic that if you've got customers in Japan or customers in North America that you want to target. Or we can do simple things like this. We can implement a user agent matching, right? So I'm going to target Firefox here. How many Firefox users do we have in the room? Cool. So I'm going to go ahead and implement this. And what we see here is that it's going to first run this rule to match, and it's going to look for Firefox, and then it's going to route those people to version 1. If that fails, then it's going to default back to this route, send people to version 2. So Firefox people, you get the old version. Let's go ahead and quit out of this, and kubectl apply version 3. Cool. So now if I flip back over, right, I've got, this is Chrome. I'm going to keep refreshing. I get version 2. I got Firefox over here. That's only going to give me version 1. So if you're out there on your phones, how many Firefox people again? Hit it. You should be getting version 1. Yeah? See some head nods. Everybody else on Chrome, version 2? Yeah? Cool. So again, makes it much more interesting, much more control over what we'd normally get. Cool. So what else can Istio do? It can do a ton of stuff. There's a lot of really cool stuff that it can do around, again, timeouts and retries. So you can set timeouts per service and have it retry or retry different pods. You could have it route around things. You can have it return different results. You can do chaos engineering, which is really cool with Istio. You can have it automatically start to inject faults and see how your systems handle that. So there's a ton of stuff that it can do. There's a link to the documentation. As mentioned before, my goal in this really is to get you guys out there, encourage you to play with Istio. But just to recap, so what have we covered, really? Service meshes give you a lot more control. So if you're using Kubernetes already, you want to go and play with Istio. You want that extra control. That control allows you to do things like Canary deployments. If you're doing Canary deployments, really start thinking about how you can target people, right? Think about representative sets. Think about the granularity as you start to crank up those knobs and continue to deploy. When it comes to Canary deployments, you absolutely need good monitoring. So if you don't have monitoring that allows you to set arbitrary tags, arbitrary metadata, to start to parse out where metrics are coming from, you absolutely need that. And if you have a tool that's doing monitoring that doesn't have machine learning, if it doesn't have outlier detection or anomaly detection, you'll want to get those tools. There are some good open source tools out there that can help provide that you can kind of tack onto some of your systems, but ideally that would be built into your monitoring systems. And then finally, what to watch for. I like the acronym LETS. So latency, errors, traffic, and saturation. Particularly with errors, remember, take a look at the type of errors that you're getting, not only the rates, because you will get new errors. And if you're just looking at your error rate, things like maybe just a 500 count or a 400 count, that may not be indicative. You may be missing things. Again, look at your traffic and your saturation. Things going up may not be bad. It could be good depending on your use case. So you have to be very wise there and understand what your applications are doing. And then I can't say it enough. Go play with Istio. Istio 1.0.3 is currently out. 1.1 is waiting in the wings. It should be out shortly. But it's a fantastic project. We need more people playing with it, using it, help highlight issues that you have, always trying to make it easier. That said, welcome to any questions. So, yeah.
So when you have monitoring, assuming that you have fantastic monitoring, is there some way that you can connect automatic approval or whatever of the Canary deployment with Istio? Or do you have to do that manually with kubectl apply when you're happy?
Yeah, so the question is there an automatic way to continue the Canary deployment within Istio rather than having to do it manually, right? So we say you should stop, you should monitor and check things out given some period of time. Because Istio is all API driven the same way that Kubernetes is, it's pretty easy to actually set that up. You could just, whatever monitoring system you have probably has some sort of integration, whether that's webhooks or other things, where you could essentially set a counter of after 24 hours of it being good, continue to ramp up. Yeah, so it's really easy to automate.
Thank you.
So there's another question over here.
Yeah, can you talk more about how you automate your deployments?
Yeah, so the question is, can I talk more about how we automate our deployments? Are you asking specifically for Datadog?
No, you mentioned something about some webhooks, but how do you do that?
Yeah, so to dive deeper into the previous answer, it really depends on your monitoring tool and what you're using out there. Most monitoring tools have some sort of integration or hooks, so you can essentially fire off things. It's the same thing, or the same concept of when I have a monitoring tool and I have my CPU goes over 90%, send me an alert, right? Monitoring tools are designed off of this idea that you're checking for something, and if it happens or it doesn't happen, then do something else, right? That's what a monitoring tool does at the very base level. And so that doing something else for a lot of the systems that are out there could be integrations with monitoring, with webhooks or other integrations, which allow you to write your own custom code and your own custom logic to then fire things off. Does that make sense? Okay. There was one somewhere up there in the middle, I thought. No? All right, we'll come back over here then.
All right, so we do something like 10 or 20 deployments per application per day, right? You're talking about monitoring for 24 hours. Do you think that it's reasonable to expect to do Canary deployments for like every single thing, or just when you're testing like dangerous things?
Yeah, so the question is that essentially if you're doing a lot of deploys a day, like 10, 20 deploys a day, is it reasonable to wait a long time? Do you want to do Canary deploys for each of those, or is it just for larger things? And generally, I say that it's for larger things. Within Datadog, we don't do a Canary deploy for every single deployment. Generally, all of our small deployments roll up into a larger feature. And so primarily, we do it when we're rolling out big features or big feature changes. But for the small things of like, there's a minor bug on this page that someone hits, like, we're just going to roll that out and not Canary it. Any other questions? Cool. Well, thank you all for coming. As mentioned in one of the slides, if you do play Pokemon Go and you want a sticker, I do have Kubernetes Squirtle stickers. So come on down. Thanks.